For this proof, we're going to use algebra, and we're also going to use the segment addition postulate. We have as a given that PR is equal to 46 and that I have to prove X is equal to 7. So let's look at our drawing here. I have segment PR. I also have additional given information, 2x plus 5 and 6x minus 15. These are the lengths of the distance between PQ and the distance between QR. Already I know I have to use the segment addition postulate. And I have to use algebra to solve this. So I'm just going to write here on my figure, I'm going to write that this distance PR is equal to 46. That's what the given statement says, 46. And then my plan is to use the segment addition postulate to solve that equation and solve for X. So let's see. I can write that 2x plus 5 is plus 6x minus 15 is equal to 46. How do I solve this? I combine like terms. 2x plus 6x, that makes 8x, and 5 minus 15, that makes minus 10, equal 46. Next step is to add 10 to each side, because we want to isolate the variable term, which is 8x. We want to leave it alone. So that leaves me with 8x on this side. Negative 10 plus 10 come out to be 0 equals, and 46 plus 10, 56. And then I divide by 8 both sides, and I get that X is equal to 7. And I've reached my proof statement. Now, how do I prove all of these steps that I did here? And you may think that this is a short process here, but once we start writing out each one of the steps in the proof column, you're going to see that we're going to have to provide valid reasons for each one of the steps that we do here. Okay? So let's go ahead and start. For my first statement, I'm going to write my given. PR is equal to 46. I'm also going to write the other given information that is in the figure, which is that PQ is equal to 2x plus 5, just to provide evidence of the information I do have, and that QR is equal to 6x minus 15. Remember, this is like being in a court trial where every little thing you present, you have to provide evidence for, okay? Let me erase that too because it's a 1. So all these 3 statements here that I've written as number 1, I'm going to say they are given information, okay? The next thing I did in my plan is I said I'm going to use the segment addition postulate. So before I write out my equation, I'm going to write the segment addition postulate. I'm going to say that PQ plus QR is equal to PR. And how do I know that? By the segment addition postulate. Segment addition postulate. Okay? Now, once I've stated the segment addition postulate, I can now use the substitution property of equality. I know what PQ is. Here it is, 2x plus 5. I know what QR is, 6x minus 15. And I know what PR is. So I'm just going to rewrite statement number 2, but with their values written in, substituted into this statement. So PQ is 2x plus 5 plus 6x minus 15 equals 46. And how am I able to state this equation? What is a valid reason for this? Well, the substitution property of equality. That lets me substitute a variable for a number. Now, make sure to reference. You have to tell me, how did you get here from these statements above this point? Well, this is what I did. I took statement number 1 and I substituted it inside statement number 2. So I referenced that. Okay? Step number 4, or statement number 4. what did I do here to go from this statement to this statement, which is 8x minus 10 equals 46? I combined like terms, 2x plus 6x. Now, it may seem trivial to you to say, well, 2x and 6x is 8x. Let's just write 8x minus 10 equals 46. But you have to be careful. Before you do that, who allows me to add 2x and 6x and get 8x? What property do I know that lets me combine like terms? And that property is called the distributive property. Okay? And it's because of the distributive property that I'm able to add 2x plus 6x. So let's see how that works. Here's what I'm going to do. I'm going to join 2x plus 6x. And this step that I did here, plus 5 minus 15 is equal to 46. I joined the variable terms together, and I joined the numbers together. And what I did here was I took 5 and 6x and I switched their positions. Instead of having 5 plus 6x, I have 6x plus 5. And I can do that because there's a property that's called the commutative property, okay, of addition that says, here's what it says. I'm going to write here to the side what this property says. It says that A plus B is the same thing as B plus A. In other words, 6x plus 5 is the same thing as 5 plus 6x. So I can switch their positions, okay? And that's what I did here. I switched them. I had 5 plus 6x, now I have 6x plus 5. Why did I use the commutative property? Because I need to have the variable terms together first before I can use the distributive property to combine the like terms. So for step number 5, and in class, when we did this in class, I think we skipped this part just because you were so overwhelmed by all the steps we had to do in order to get to x equal to 7. Then I just skipped this part so that you wouldn't be so frustrated. But this is very important. This is a very important part. You know, everything I do, every little thing I do has to have a reason for doing it. And I'm stating it here, okay? Now that my variable terms are together, 2x plus 6x, look at the common terms between them. 2x and 6x have something in common. They both have x. Okay, so I can factor, or I can use the distributive property to say, well, I have, this is a parentheses, I have 2 plus 6 times x. I take that common factor and I write it outside of the parentheses. And I can say that 2 plus 6 times x plus 5 minus 15 is equal to 46. Okay? And this is, I can do this by the distributive property of equality. Okay? So there's a reason for each little thing that we do. Now that I have 2 plus 6 in parentheses, these are just basic numbers, basic addition, I can go ahead and say 8x minus 10 is equal to 46. And for this, what's the reason for me to say this? Well, a valid reason is we had addition, so we simplified. This step we called simplification. Okay? Anytime you add or subtract numbers, you validate it by saying that you simplified. Okay? Now look at this. From this step all the way to this step, which when we do algebra, we do all in our head, we're really breaking it down. We're right here. We're breaking it down into very precise steps. We're looking at every little thing that happens in between here that we do in our heads and we don't realize it. We don't realize that we're using the commutative property and the distributive property when we do this sort of operation, okay? But when we're doing two-column proofs, we need to show that all these things happen. And I'm running out of space here, so I'm going to erase later. Okay, for step number 7, the next step that I need to do is add 10 to both sides. Now remember the last time we did a column proof with algebra. It said that if I add the same number to both sides of the equation, then I will end up with an equivalent equation. So first I have to state that the number that I'm going to add to both sides of this equation is the same number. So I have to state that 10 is equal to 10. Okay, by the reflexive property of equality. Reflexive property of equality. Okay? That says that a number is equal to itself. And since the addition property of equality states that I have to add the same number to both sides, I first validate that the numbers that I'm adding to both sides are really the same number. So this is a way to say, look, I'm doing things correctly. I am adding the same number to both sides. And let me erase my plan here so that I have some room. Okay, so we're all the way up to step number 7. Let me write step number 8. I think it fits. Step number 8 would be to go ahead and add that same number to both sides. And when I do add 10 to both sides, I end up with 8x equal to 46. Okay, and how did I get there? Well, by the addition property of equality. Okay, I'm going to continue over here. Step number 9, or statement number 9 for me would be, I know my next step is divide by 8 both sides. But before I divide by 8, I have to state that 8 is equal to 8, because the division property of equality says that if I divide both sides of an equation by the same number, then I will end up with an equivalent equation. So I have to demonstrate first that I am using the same number, and that I do by saying that 8 is equal to 8, and I validate it with the reflexive property of equality. And for statement number 10, now I can divide by 8 on both sides. And when I do that, I end up with x is equal to, whoops, this isn't 46. I'm sorry, this is 56. 46 plus 10 is 56. Let me fix that. Let me erase this here and write it more nicely. 56. Because I added 46 and 10 make 56. Okay, so now I divide by 8 both sides, and x is equal to 7 when I divide by 8. And reason number 10 is the division property of equality. And you're done. I hope you understood this problem. It has a lot of steps, but isn't this just beautiful how all of these things exist, all of these properties that we've been hearing about, I think, since 7th grade or 6th grade maybe, the commutative property, the distributive property, and how all of these properties validate each and every one of the little steps that I have to take in order to solve an equation. So there you have it. I'll see you in my next video.